So we're going to do some balancing. That's one thing. Share screens. So, what are we talking about? Let's get right back into it. So, example of balancing acidic solution. HCO plus minus goes to C2 plus N2 plus. So, I can go ahead and break this. HCOH goes to CO2. Split this in half. Minus goes to 2 plus. Now, do I need to identify the substances here? Do I need to identify which is the solution, which is the reaction? No, you don't have to. You can, but you don't have to. I'm not going to do that. So I have my half reactions. I'm going to look at carbon and Mn bonds. And both of those are fine, so I'm going to leave that as part of this. Now I'm going to look at oxygen with H2O. That didn't get really well, but that's okay. HCOOH. 2 oxygens goes to CO2. 2 oxygens. 2 on both. This is an MnO4 minus going to an Mn2 plus. H2. Okay, awesome. Now we do H with H plus. And I see that I have HCOH on that side going to CO2, but there are no protons, so I need to have the 2H plus added to my product side. I also have 8 protons that I added in adding the water, so I need to make sure that I have 8H plus MnO4 minus goes to Mn2 plus 4H2. Oh, cool, awesome. Now I've done everything but carbon and hydrogen. Everything but oxygen and hydrogen. I did the oxygen, I did the hydrogen. Now I need to look at my charge balance. So charge. I have on this reaction side in the HCOOH, this is neutral. I have a +2 on my product side, so I'm going to add 2 electrons to that. HCOH goes to CO2 plus 2H plus 2E minus. And of course, we have an 8H plus, subtract 1, that gives me a 7 plus. And then we have 2 plus on the other side, so we need to add 5 electrons. So 8H plus MnO4 minus 5E minus goes to Mn2 plus 4H2O. I see that I have 5 electrons in the Mn and only 2 electrons in my carbon. So I need to multiply carbon by 5, Mn by 2, and that gives me 5HCOOH goes to 5CO2 plus 10H plus 10E minus 16H plus 2MnO4 minus plus 10E minus goes to 2Mn2 plus 8H2O. Cancel the electrons. And when I look at this, I see that in the product side on the carbon reaction, I have 10 hydrogens. In the reaction side, I have 16 hydrogens. So I can cancel this 10, and instead of this being 16, it's going to be 6, because I subtract out the 10 that I'm canceling. Okay. Some possum. I don't have any waters in common. Nothing else is common, so we go ahead and add this. Try and give myself a little more space. So 5HCOOH plus 6H plus, because it canceled some, plus 2MnO4 minus gives me 5CO2 plus 2Mn2 plus 8H2O. Okay, awesome. So let's check this. HCO Mn charge. And that should be everything. So again, looking at my reactant side first, I have 10 hydrogens, 16 hydrogens total, because I have 5 at the beginning of this HCOH, 5 at the end, so that's 10, plus the 6 here, that's 16. And if we go here, 8 times 2 is 16. I wasn't going to do it that way. Okay, let's go back to our reactants. I have 5 carbons from the HCOOH. I have 2 in this molecule. 2 oxygens times the 5 is 10. Plus the 4 times 2 is 8. So 18 oxygen. And I have 2 Mn. Total charge. I have 6 plus minus 2. That gives me 4 plus. Okay. We look at our carbons. We have 5 carbons. Cool, that matches. I have 5 times 2 is 10 oxygen plus 8 from the water. That gives me 18 oxygen. I have 2 Mn. If I look at my charge, the only charge I have is from this Mn2 plus. There are 2 of them, so that means my charge is 4 plus. Everybody's balanced. Everybody's happy. Cool. Here's the thing, though. You may recognize, wait, MnO4 minus. That sounds really familiar. That's 16H plus 2MnO4 minus. Yeah, it is really familiar because it's exactly what we had in this one. 16H plus the 10E minus plus 2MnO4 minus plus the 2Mn2 plus H820. Now notice, up until a point, we only work with these as half reactions, right? When we get to the point where we need to see, do we have the same number of electrons in both places? Then we have to start looking at combining these two things. But what that means is that if I can find a reduction reaction, it's going to be balanced on its own. And so I can work with that. And one of the things that we have, and I'll actually pull it up. Take me a minute, sorry. I haven't pulled this in it. So if you go to content in the course documents, you'll see exam handouts. Exam handouts. If I scroll down, there's a bunch of really useful information in here. That's what I put together. Standard reduction potentials, 25 degrees C. So it gives you a reduction half reaction that is balanced. So all of these are balanced. I don't need to check the balancing on those. So if I can find it in there, then I don't have to balance it again. I can use it as written. Okay, we'll talk about the rest of what that table is about later. We're not to that part yet, but that's what we've got there. So these tables are meant to be useful to you. There are things all over them that are helpful. So there are equations in here that you may want to be looking at, things that calculations. A lot of the calculations we're going to be doing in the next exam are in this section. So there's that. There's unit conversion. I give the same set to both my 110 and my 111s. But notice there are common polyatomic ions. So when I was talking before about Cr2O7 minus, that's dichromate, Cr2O7 minus. So that's how I knew that was a 2 minus charge. So these are very helpful to you. One of the other things I'm going to point out to you is that any strong acids or strong bases are in this list. If they're not in this list, they are not strong, in which case they are weak. Sometimes you will find them then in the weak acids, weak bases that we have, but not always. That doesn't mean it's not a weak acid. This just means that these are the KBs and KAs I felt like giving you. Okay. This is about the salt properties that we talked about previously. So you'll see that this is on the test to help you with that. If you know what that table means, there's some common names because I throw those around. So make sure that you're checking here. If I say slake lime was used too, you can come in here and see what slake lime is. There's some heat capacities which we may need to use. And don't forget that your stoichiometry stuff is here and your fun bars, so that you know how to calculate between H plus, OH minus, POH, and pH. Okay. So that's most of what's in there. Just wanted to point that out too when I was talking about the standard reduction percentage. Here. So there is what we're talking about for that. And that half reaction is the same. So let's talk about this in a basic solution. So we're talking about chromium hydroxide, CrOH3. Cr is a 3 plus, it's an OH minus. So 3 plus bromine gas, Br2, gives me CrO4 2 minus and Br minus in basic solution. Okay. To start with, this is no different than what we've done previously. Half reaction that involves the bromine and half reaction that involves chromium. I write the chromium first because it's the first thing that's written down. CrO4 2 minus. I also have the Br2 going to the Br minus. My first check is to see where there are chromiums and bromines on both sides, and I do. I have one chromium on reactant and product side, but I don't have the same number of bromines. I have 2 bromines as a reactant in this reaction over here, Br2, but I only have 1 Br minus, so I'm going to need to multiply that by 2. Now, can I do that in that first one? Yeah, I can. I don't always. It depends on what I'm doing. So my next step is balance for oxygen with H2O. So CrOH3 is CrOH4 2 minus. And I have 4 oxygens on my product side. I have 3 oxygens on the reactant side. So I'm going to need to add an H2O. Squish that in there because I didn't give myself enough space. I don't have any oxygen or hydrogen that I need to worry about in this reaction right here, so I'll go ahead and rewrite it. Next, we're going to deal with our H with H plus. So I have 3 H's from the chromium or 5 with the hydrogens. I don't have any on my product side. So that's going to give me a CrOH3 plus H2O, give me CrO4 2 minus plus 5H plus. And of course, I don't need to worry about the Br2 to R. I just don't want to leave it hanging out up there, so I'm going to pull it down. The next thing you need to worry about is charge. Okay, so I have my CrO3 minus plus H2O goes to CrO4 2 minus plus 5H plus. So on my reactant side, I have no charge. On my product side, I currently have 5 plus minus 2 gives me 3 plus. So that means I need to add electrons there. CrOH3 plus H2O gives me CrO4 2 minus plus 5H plus 3 minus. And I have my Br2 going to 2B minus. I need 2 E minus to balance that. Okay, awesome. So I have 2 electrons in my bromine, 3 in my chromium. I'm going to have to do some multiplication here too. So we're going to make E minus same I'm going to multiply these reactions, one of them by 2, the other one by 3. So when I multiply, I have 2CrOH 3 plus 2H2O 2CrO4 2 minus plus 10H plus 6E minus. We have 6E minus plus 3R2 goes to 6ER minus. Same number of electrons on both sides, so I can cancel that. I don't have any H plus or OH or H2O in common between the two of them. So now I can add. And I get 2CrOH 3 plus 2H2O plus 3B2. Gives me 2CrO4 2 minus plus 6Br minus plus 10H plus. Yay, I'm done, right? No, it's a basic solution. It says basic solution. Okay, fine. I said we would fix it. The way we're going to fix that is to add the same number of hydroxides as we have H+. So we have 10 H+ over here. We're going to need to add 10 OH minus plus 2 CrOH 3 plus 2 H2O plus 3 Br2 gives me 2 CrOH 2 minus plus 6 Br minus plus 10 H plus 10 OH minus. These two together become 10 H2O. So now I have 10 H2O on my product side. I have 2 H2O on my reactant side. So I'm going to cancel the 2 H2O there and turn that into an 8. And so just to clean it up, 10 OH minus plus 2 CrOH 3 plus 3 Br2 goes to 2 CrO4 2 minus plus 6 Br minus plus 8 H2O. And if I am to check this, OH, CR, Br, and of course I didn't lay myself at a firm, so I'll do the charge above this. Sorry. I have 6 bromine on my reactant side. I have 10 oxygens from that OH minus. 10 plus 2 times the 3, 16 O's. I have 10 H plus 6, so 6, 16 H. I have 2 chromiums. And my net charge on this side is 10 minus. If I look at my BRs, I have 6 BRs. I have 8 oxygen there, and 8 times 2 is 8 is 16 oxygen total. I have 8 times 2 is 16 hydrogen. I have 2 chromium. And I have 2 times 4 is 4 minus plus 6 minus is 10 minus for my charge. Everything is balanced. So all we did in doing that correction was add the same number of OH minus to both sides because I don't have any H plus. So I need to get rid of that by adding the OH minus. That turns into water. Then I have the OH minus there, and now I'm good. Okay. So that's how that process works. Hopefully there are no questions about it. If you have questions, comments, problems, concerns, you know the drill. I am more than happy to deal with that. Let's talk about this one. ClO2 minus goes to ClO2 plus Cl minus. Well, this is entertaining. Why is this entertaining? Because I have the same reactant in both of these. So one of my half reactions is going to be that one, and that's going to give me a ClO2. My other one is going to be a ClO2 minus, giving me Cl minus. Okay, so those are my 2 half reactions. Because I only have the one species on the reactant side, I have to use it in both of those half reactions. So I have 1Cl, 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 1Cl. So my chlorines are balanced. Okay, let's do O with H2O. So I have 2 oxygens on my reactant side, 2 on my product side. I have 2 on my reactant side. It's a Cl minus plus 2H2O. So this one didn't need it, and the other one did. Let's skip writing it at this point. H with the H plus. This one, since it was good for the oxygen, is also good on the hydrogen because there aren't any there. But on this side, I screwed up my hydrogen when I added that 2H2O. So that's 4 hydrogens that I added. So 4H plus Cl2 minus goes to Cl minus plus 2H2O. Okay, awesome. Now I deal with charge. ClO2 minus goes to ClO2. Notice that there is a minus charge on one side, not on the other side. So ClO2 minus goes to ClO2 plus an electron. Over here on the reactant side, I have a 4 plus minus 1, that's 3 plus, and I have a minus 1 on the other side. So I need to go from 3 plus to 1 minus. So if I add 3, that gets me to 0. But I need 4 to get to that negative. So 4E minus plus 4H plus ClO2 minus ClO plus 2H2O. Okay, awesome. I need to multiply both of these by 4 to make the number of electrons the same. So I have 4 ClO2 minus just a 4 ClO2 plus 4 electrons. 4 electrons. I'm not actually going to write that because I haven't changed anything. So I have 4 electrons in both of those half reactions. Now, one other thing. I have 1 ClO2 minus in the second reaction, this one right here. And I now have 4 from this reaction right here. So when I add these two together, I'm going to have 5 ClO2 minus plus 4H plus gives me 4 ClO2 plus a Cl minus plus 2H2O. And if I look at that, ClHO, and that's it. So my reactant side, I have 5 Cl's, 4 H's, and I have 10 oxygens. On my other side, I have, didn't carry that. Okay. So this should have been a 4 right here, because I needed to multiply this whole thing by 4. So that should be a 4. And, wait, is that right? No, never mind. Sorry. Wrong mistake. See, it gets convoluted. I have 4 chlorines and 1 chlorine, that's 5 chlorine. I have 4 hydrogens, 4 times 2, and then I have 4 times 2 is 8, plus the 2 is 10 oxygens. My charge on the reactant side is a -1, because I have 5 minus the 4, that's a -1, and on my product side it's also -1. Everybody happy, everybody balanced. Cool. As long as you don't confuse yourself when you try to add stuff, you should be fine. But again, for me, that's important. So my process in my head, I was like, oh wait, I only have 4 on 4 chlorines on the product side, and it's because I thought that I had messed up the math there, so I had to go back and check my math and that kind of stuff. But again, that's easier for me, so that's how. Sorry, I apologize. And one more in base. Let's do one more in base. So I have oxygen O2 going H2O2. because the Sp goes to the SpO2. So I'm going to do O2 goes to H2O2, and I have Sb goes to S2. All right. So I have one Sb on both sides. I have nothing else that I need to worry about. So my half reactions and Sb are good. So now we're going to deal with the oxygen with H2O. I have two oxygens. Cool, that's fine. Over here, not so fine. So I need 2 H2O plus Sb to give me an SbO2. Now, when I get to the H with H plus, this one is a mess. So I have two hydrogens here and none on the other side. So I have 2H plus O2 gives me H2O2. And then I have 4 hydrogens here and none on the other side. So 2H2O plus Sb to give me SbO2 plus 4H plus. Now I need to know, how do I get my charge even? So my overall charge on the reactant side over here is 2 plus, 2 hydrogens, so 2 plus. So I need to add 2 electrons. So it's going to be 2E minus plus 2H plus O2, give me H2O2. Everything's net neutral, so 0 across the board. Here I have no charge on my reactant side, but I have a 4 plus on my product side, so I need to add 4 electrons to the product side. So that's going to be 2H2O plus Sb gives me SbO2 plus 4H plus 4E minus. Not the same number of electrons. I have 4 in my Sb reaction and only 2 in H2O. So I'm going to multiply this by 2. 4E minus plus 4H plus 2O2, 2H2O2. Actually, I don't need to write that one. So I have 4 electrons there and 4 electrons there. I have 4 protons there and 4 protons there. And everything else stays because I have nothing else in common. So what does that leave me? Well, it leaves me with 2O2 plus 2H2O plus an Sb. And that gives me 2H2O2 plus an SbO2. All right, let's check. O, Sb, charge, and H. I'm just going to throw H right there. So I see 4 H's there. I see 6 oxygens. I see 1 Sb. And my overall charge is 0. I have no charge on that side. Look at my other side. I have 4 hydrogens. Had to check my math. 2 times 4 oxygens. 2 times 2 is 4, plus 2 is 6. I have 1 Sb, and I have 0 charge. So yay, my math has worked out again. But is that going to work? It actually is. And I say that because I have no H plus left. So this is balanced in base as well. So I don't even have to do that part. Cool, awesome. We love it when that happens. All right? So that's how we deal with that. Questions, comments, problems, anything. I hope not. We're going to take a break here, finish with our balancing. We're going to stop that. We're going to stop this. And I'll see you soon.